Hi everyone, welcome to learn the algorithm with me together. Today let's take a look at the 206 reverse linked list. And what is this problem talking about? We will be given the head of a single linked list and then reverse the list and return the reversed list. So here's an example. Like we have this kind of linked list 1.22, 2.23, 3.24, and 4.25. And then what we expected to have is like 5.24 instead 4.25 and 4.23 instead 3.24, etc. So this should be the whole reverse linked list. And now how we can do that? Like we have so many nodes, so it's pretty complicated. And probably we can like assume that we only have like two nodes, right? That'd be much more easier. Just like the idea of like the recursive way. What is the recursive? Just is we can break the big problem into a small problems. So the smallest problem is like we may only have like one node, right? If we only have one node, definitely there's no need to reverse it. But how about we have two? If we have two, how to make the 2 pointed to 1? Well, like here is the head. It means the node 1. And then how we represent the node 2, that could be head dot nest will be our node 2. This is the node 2, right? So the node 2's nest node will be look like this. And the node 2's nest nodes pointed back to 1, so it means that node 2's nest node can equals to the head. That's how we point it back. After we point it back, what we need to do, we need to disconnect it, this node, right? Disconnected one pointed to 2. So now the next step is disconnect. The first step is just, we can say point back, right? So how we disconnect is the head nodes nest well equals to now. So now the head node is pointed to now, right? So now we already got the new reverse linked list, but how we return it? We lost the track. So it means that when we are pointed back, we definitely need to have a new head, right? So before that, we need to have a new head pointed to here. That's how we do. So now before the whole steps, we will have like a new head. And how we do that is we make a new list node, and the new head will equals to the head nest, right? We have to store this information into the new head node. All right, so this is the smallest problem we can solve, like only have two nodes. And now how we expand it to a more complicated problem, right? This is how the recursion do. And all right, now let's move this part, the smallest problem, ahead. and we continue to use the original example. So we can say this is the smallest problem. Which means we only have 2 nodes. Now we can assume that the whole completed linked list, if it has multiple nodes, right? We assume that they are just break it down into 2 parts, like this. And the left side is just 1 node. This is as the whole node. And the other side is also another whole node. And for the right side, we can assume that it already reversed, right? We assume that we already reversed it. So when we reverse it, as we said, we definitely have to have a new head to store it so that we won't lose the track. Now, how we do that? Let's say this could be the new head, right? Just as our step 1, we have a new head to store it. And then this could be our current levels head. And current levels head, the next node. Now, our problem is like, if this is like 2 nodes, how we make the right side point it back to current head, right? So it means that for this one, we need to point it back as our second step, right? So now, or maybe we can, this is our second step. We point it back. So now we point it back is just exactly like the same. Is head dot next, point it back to head, right? And after we point it back, we need to do what? Disconnect it. Disconnect it, this part, and it will point it to null. So now it would be like head dot next equals to null. And also, as we said before, we store a new head. So this new head is just called our function, right? The whole function for like its next node, how we do that. And so if you're still confused about these steps, all right, so let's talk about this part. So now we already reversed this, right? And we just can return this head to the last level. Return the new head. That's how we do, right? And now how we can think about this recursively. I'm so confused. Now I just tell you like we can think about the whole linked list split into 2 parts. One is like including 1, 2, 3, and another part is 4, 5. And now after we complete all these things, what will it look like? Yeah, we already go back to last level. And now we come back like this, and now we only have 2 parts again. And the head node is not at 3 anymore because we are going back last level if we add 2. And now just what we are seeing before. In the right box, right? In the right box, the whole linked list is already reversed, right? you can see that you already reversed. And at the node 3, it also pointed to now. This is what we expected. And we can just do the whole steps again, like the head is how we make 3 pointing back to 2 is using this step. And then our head node also needs to disconnect it. Is this how we can disconnect it? And then we return back this whole head. And this is how the sub-problem we solved. But how we can come up with this idea, right? This is a recursive way. I think this is the original list. Why? It just like we have this node. Now, this is our head node. And she's asking the rest of the linked list, hey, have you already reversed? Just like the first call. And the node 2 said, oh, I didn't. Just let me ask then my next node. So then the number 2 asked the 3, or have you already reversed? So the 3 is managing the remaining list, right? And the 3 said, oh, I'm sorry, I don't know. I asked the 4, right? She asked 4. So the 4 managed the remaining nodes is 4 and 5. And of course, 4 responds saying, I'm not sure. Let me ask my next one. Right? So the 4 asks 5. So that's how we do the recursive. And 5 only has himself. And this is our corner case. When we only have like one node or the node is already null, we just stop it. We just return itself, right? So the 5 says, okay, I already done it. So the corner case is if this node is already null or its next one is also null, we can return itself, right? So now if the 5 already reversed, it goes back just like these ideas. So the 5 now can reply for, okay, I already done everything. Let's turn back. So 5 is already done this. We can forget this. And now the 4 know that, and it started to implement this recursive, not recursive, like reverse the linked list part, just like this part. So now after the 4 doing all things to reverse the list, right? It also can start to go back to tell 3, hey, I'm already done. So you can do whatever you can do. So we go back anything and until the 1, and it can also like doing the whole things. After doing the whole thing, we just return the new node, a new head here. So this is how the idea of recursive, right? Now we understand the recursive. So what is the time complexity? Because we have to traverse the whole linked list, so the time complexity is big O N. And how about the space? Because the recursive, we always use a stack to remember which step, which level we are working on. So also it's the big O N. So this is how the recursive do. And now probably we can use another way is iterative, right? And here is the linked list again. 1 pointed to 3, pointed to 4, and pointed to 5. How we do the iterative way? Like now we need to some other pointers help. This is our head, right? And how we are make it the next one, point it back to 1, right? So if we are making it pointed back to 1, it means that it will be disconnected. Like the number 2 won't never connect it to the 3. So like this, we already lost the track of the remaining list. So now what we do, we definitely like before we are pointing back, we have to have a temporary nest to keep track of it, right? So, or probably we can just say nest node here, keep track of it. After we have this, oh wait, let's get a step back. Because the first thing is so the first thing is we need to make it this one right. So now like the first thing is we need to make the first node to point it back. So if we are made it point it back, the rest of the node list we will lose the track. And if we point it to null, right? So how we can keep track of it is before we point it back, we have to have a nest node here to keep track of it. So that's how we do the nest node equals to head.nest, right? After we have this, we can also have the previous node. Here, of course, at first we can have a previous node equals to null, and then we also have a nest node to keep track of the rest of node. And after we have this preparation, now we can do that. The head.nest can point it to the previous one, right? So now we can do that now. And then after that, what we're gonna do is we can move all these pointers one step. So is there something we need to care about the order? Yes, definitely. Because like if you are moved the head before, we first move the head and then how we move the previous pointer. No, we cannot do that. We lost the track for this node 1. So definitely we need to move the previous first. So the next step is just move previous node first. Move previous to head, right? And then we move the head to the next node. And how about the nest? Probably we don't need to care about that because every time we can just new nest node here, right? Because nest node is just next to the head, or as we said here. So that's how we do the nest node will always be here. Then when we stop this situation, and oh yeah, so probably we are not saying this is the head because we can keep the head still this one. In case anything, we can just have a new current node here to point it to instead of as our head node, right? So when we stop it is when the current node is moved to here, right? If there is nothing, it's now. We don't have to make the current node back to the previous node. But if the current node is still the last one, we still have to, like here, if like this, we still have to make the current node point it back to the previous node. So when we stop is when the current node is equals to now. So when it's not now, we have to do all these things, right? And this is how we do. And when the current node is moved to the now pointer, it means the previous node is already at the end of the linked list. And we said it's an end of the linked list. It's also the new head of the linked list. Now the previous pointer is new head of the linked list, right? Reversed linked list. So we just return the previous one, right? So for this one, what is the time complexity? The time will, yeah, definitely like O, big O n, because n equals to all the nodes, because it still traverses the whole linked list. And how about the space? Because it doesn't use extra like data structure, not like the recursive way. Recursion is always use the stack and cause an extra space complexity, so it will be like constant. And by comparing these two methods, one is this is the recursion, like this is incorrect, like recursion, and this is will be the iterative way. So we'll definitely choose the iterative way. And now let's move to the coding part. Like I will type the coding part. Let's do it again. I forget to clean the results. It's okay. All right. So if we are working on the iterative way, so how we do that is this node. We will have a previous node first, like pointed to now, and then also have a current node pointed to our head. And while our current node is not equal to now, that's what we said here, right? We can say we can start our reverse process. This node, we have a temporary next node pointed to next, and after we have this, we can start to reverse, right? Head.next pointed to previous. After that, move the pointers. How we do that is the previous one is equal to head, and the head move to the next, and that's it. And then finally, which one we need to return is this, the previous one. Is our new head, return previous. And as I said, what is the corner case, base case is like, is this pretty simple one. Like, how about we have only two nodes, right? Here, we only have one node or two nodes. Like, if we have one node or just no node, we definitely just return that original one. So if the head equals to now, or it just a one node here, we can just return head. So that's our corner case, right? And yeah, that's the whole idea, like the iterative way. Let's run it. All right. So the head nest is equal to null. Let me think about that. All right. We are not moving the head, we are moving the kernel. My bad. So now let's run again. Find the cycle into it. Let me think about how we move the previous node to the, oh, not to the head, we are saying that to current. Why we lost one? Yeah, it's still, the problem is current. Our current node's nest equal point to previous, and the previous one moved to current, and the current moved to nest. Y is previous to current and current to nest, and let's say previous move to current, like we have the 1.2, 0.3, 0.4, 0.5, and we have the previous as now first, and then we have current, and now after that we initialize the nest here, and now the current pointed here, we point it to previous, that's right, and then we move the previous node ahead, right, and now we initialize another nest one. I also point it to here, here, and now the currents point it to back. At least that will be like half. Let me think about that. So that's right. The current nest is previous one. All right, here it is. Still, the current point is here. It's not head one, correct? And this is the recursive way. Let's submit it. All right, so we pause it, and this is the iterative way, and I believe is the, we say the most space saving plan. And also I can show you like how we do it like recursively. Now let's go back, and the recursively is this kind of pseudocode, right? Now if also the current case when we stop is when head null equals to null, or head.nest is null, we can just return the current head. And then we need to have the new head here, right? New head equals to this function. We ask the next one. Have you already reversed it, right? When we have the new head, what we do for the current head, next equals to head, and head.next equals to none, and then we return the new head. So this is the recursive way. Yeah, we can pass all the test case and submit it. Yeah, no problem. So now for these two so for how we reverse a linked list, we have two ways. One is recursion, another way is iterative. And I will more highly recommend it to use the iterative way, because we don't need to use the extra space to store the which level we are at now. But more easy to understand, sometimes it's just recursive way, but never mind. And hope this video helped you to learn the techniques about recursion and iterative. If you think these videos help you, please give me a thumbs up. That would be a great encouragement for me. And thanks for watching.